Hello, my name is Nathan Bringleson. I am an application engineer with Yokogawa's Test and Measurement Department. Today I will be demonstrating how to perform a calibration test on the Yokogawa WT300 and 300E power analyzer series using the Yokogawa LS3300 AC power calibrator. The test accuracy ratio, or TAR, will be used to confirm the WT300's accuracy. The TAR will be discussed in further detail later in this video. I will be testing one input element using the one-phase 2-wire method, although this approach is applicable to a 3-phase 3-wire or 3-phase 4-wire method if multiple LS3300s are used. This performance test I will demonstrate provides test accuracy ratios for current and voltage of the WT300 and 300E series, as well as accuracy verification. The first thing I will show you is how to set up the wiring configuration for one-phase 2-wire in the LS3300 configuration settings. First, I will press the configuration key, then I will select wiring, next the type, and finally I'll select one-phase 2-wire. We can exit out of that screen and then exit one more time. One thing to know is there's two options for one-phase 2-wire. One is for high current output, which will not be used during this test. Next step would be to set the voltage and current ranges. To set the voltage range, I'll press the voltage button followed by select range, and then for this test we will use 300 volts. Similarly, for current, I will select the current button, select range. Next I will select 10 amps for this test, and then we can exit back out to the main menu. Finally, I will set the power factor to 1 by pressing the soft key next to the power factor. This can be found in the voltage or current menu, followed by power factor, enter in your value, pressing enter. The LS3300 allows for the power factor to be set from -1 to 0 to +1. We will also set the frequency during this time by going into voltage or current, selecting frequency, and entering in 60 Hz for this test. This instrument allows for phase angle to be selected from 0 to 359.99 Hz. We will conduct the accuracy test using the 5-point method. To perform the 5-point test, we will use the level ratio. The level ratio can be found under voltage or current right here, which allows you to set the current or voltage level in units of percentage of the range. The 5-point test method uses percentages of 0, 25, 50, 75, and 100%. For the 300 volt range we are testing here, this corresponds to 0, 75, 150, 225, and 300 volts. Using the level ratio key allows for selecting of a percentage to conduct a point of the 5-point test. Similarly, this test will be conducted on current as well. For this range of 10 amps leads to 0, 2.5, 5, 7.5, and 10 amps. For this analysis, we will use a voltage of 150 volts with a 300 volt range and a current of 5 amps with a 10 amp range, a power factor equal to 1, and a frequency of 60 Hz. These values were chosen to be 50% values of the 5-point method and are just chosen to demonstrate 1 point of the 5-point method for accuracy testing. Only 1 point is chosen for the sake of time during this video. To begin the test, I will set the output level of voltage to 300 volts by selecting the voltage key and entering in 300 volts under the level option. Next, I will select the level ratio, enter in 50%, and click enter. This will provide me with an output of 150 volts. Next, I will go into the current menu. I will set the level to 10 amps by going to level and entering in 10 amps. Next, I will set the level ratio to 50% and enter, which will provide me an output of 5 amps. The next step is I'll ensure the V1 and I1 keys for unit 1 are lit by pressing V1, I1. These keys correspond to using the instrument in a master-slave configuration and will need to be illuminated before the instrument will output current or voltage. The next step is to select the output key, which will turn the output of the instrument on and will become illuminated. The results are seen here on the WT310 power analyzer. From these results, the accuracies for both the LS3300 and the WT300 were calculated. For the LS3300 at 60 Hz, the voltage accuracy at this range and setting is a plus minus 60 millivolts, with the WT300 accuracy being plus minus 299.9 millivolts. This provides a TAR, or test accuracy ratio for voltage, equaling 4.99, passing the minimum required ratio. As well, for the LS3300 at 60 Hz, the current accuracy at this range and setting is a plus minus 2.5 milliamps, with the WT300 accuracy being plus minus 10 milliamps. This provides a TAR for voltage equaling 4, passing the minimum required ratio. The calculated accuracies for the WT300 are within the plus minus 0.15% accuracy specification for this series, and thus confirms the accuracy of the instrument to specification. I hope that you have found the demonstrations to be informative and useful. Thank you for watching. For any inquiries, please do not hesitate to contact us or visit us at tmi.yokogawa.com. Thank you.